Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So I received some audience feedbacks that the audience want me to introduce some more basic foundations of the geometry rather than focusing on solving extremely difficult problem. To be honest, we haven't touched the extremely difficult problem yet. But I think that's a good idea that we start from the foundation. So I believe most of the audience already have the background of the middle school geometry. But in the middle school, we learn the geometry in a way for the test, for the exam, right? It's not in the way for the application or in the way as a research direction. So I think the best book for this topic, like you want to learn the foundation and you want to learn more about the foundation, the deeper end, it's called the Geometry Treasure. That's a book we're going to use. And I don't think this book has an English version. So for the audience who knows how to read and write the Chinese, you can just you can just buy the book and read about it. It's a fantastic book. I believe it helps a lot in the Olympiad geometry because it's not only, it has like two books, right? And each one is about 700 pages, which means if you can finish like 1,400 pages of the geometry, you're already very strong. And I think that's also a good preparation for the Olympiad geometry. But for the audience that doesn't know about the Chinese, and no worries, we can cover this whole book in the videos. I'll make videos for this book because I really love this book. And when I was in the middle school, I don't have the chance to have such practice because at that time there's no this book, right? This is a book written like recently. So we're going to use this book as our textbook, and we're going to introduce I believe most of the content in the book. That's for, I would say, another series. Let's just call it Geometry Treasure. And at the meantime, I will continue our problem of the day and our geometry method. Okay, just in different pace. Okay, let's continue our discussion now. The first thing that I want to talk about is a generalization of the Pythagorean theorem. Pythagorean theorem, I made another series of videos that I want to introduce, like more than 200 methods to prove the Pythagorean theorem. And on the other hand, we want to check on it, find the generalization of the Pythagorean theorem. Each of them are the different ways looking at the geometry knowledge. Okay, so the first property would be drawing three similar figures based on the three edges of a right triangle. The area summation of two figures based on the castity equals to the area of figure based on hypotenuse, right? That means if we draw any figure, let's draw a right triangle first. Okay, so this is A, this is C, this is B, okay? This is 90 degrees. And we draw any similar figure. So for example, I draw a arc here, and arc here. Right, these three arcs are similar, which means the radius of the arc, the radius of the circle that arc is in would be, so for the arc AB, let's call arc AB, 2 R, arc AC, 2 arc BC should be AB to AC to BC, right? That's a similar figure property. So now we want to prove that the summation of the area of the two figures based on the chastity, which means this area plus this area equals to the figure based on the hypotenuse equals to this area, right? Let's call it S1. This is S2. This is S3, right? So S2, because they are similar, that means S2 to S2 to BC square equals to S3 to AC square equals to S1 to AB square, right? And then we know that because AB square equals to BC square plus AC square. So if we put a K here, then we can easily find that KAB square equals to KAC square plus KBC square, right? This is still valid based on this one. And what is KAB square? That is S1. And what is KAC square? That is S3. And KBC square, that is S2. Right? So we just prove this one. Okay. That's a property 1. And for the property 2, the length of edges of a cuboid is ABC. Right, so I draw it here. Right, so this is A, this is B, this is C. Right, that's the length of the cuboid is ABC. The length of its diagonal, which is from this point to this point, right? That is L. And we want to find the L with ABC. So first, because this is rectangular, so we can calculate for this distance, right? This distance is C squared plus B squared, right? This square equals to C squared plus B squared. And because this is also a right triangle, that means L squared equals to this square plus A square, right? So L squared equals to A squared plus B squared plus C squared. Okay, that's property 2. And property 3. In a right tetrahedron OABC, angle AOB equals to angle BOC equals to angle CO equals to 90 degrees. Then we have this one. So let me draw the figure first. Right, what is a right tetrahedron? That is saying the angle AOB is 90 degrees, the angle AOC is 90 degrees, and the angle BOC is 90 degrees, right? And we want to prove that the area square of triangle ABC equals to the summation of other 3 triangle area, right? Square, right? So look at ABC here. So we need to understand how to calculate the area of triangle ABC, right? So let's call the BO as B, OC as C, OA as A. That's a length, right? Now we want to calculate for the area of triangle ABC. We must find the altitude of it on the BC, right? So think about here, we find the altitude AD on the edge BC for the triangle ABC, right? And OD is always perpendicular to OA, right? So now we want to say that OD is perpendicular to BC and OD is perpendicular to AO, right? AD is perpendicular to BC. So we can calculate for the length of OD. OD square equals 2. Let's do this way. So OD equals 2 BC divided by BC, right? B times C divided by BC. That's OD. So the BC can be rewritten as squat B squared plus C squared, right? Which means OD squared equals 2 B squared C squared divided by B squared plus C squared, right? That's OD squared. And AD squared equals 2 OD squared plus OA squared, right? Which is B squared C squared 2 B squared plus C squared plus A squared. Then we get AD squared, right? So the area of triangle ABC squared equals 2 BC squared times AD squared times 1/4, right? Which is B squared plus C squared times B squared C squared 2 B squared plus C squared plus A squared, right? That equals 2 A squared C squared plus A squared B squared plus B squared C squared. Okay, that's the area of the triangle ABC. And for the other three, this one, and we need to times 1/4, right? Times 1/4, okay? And we can easily recognize that a quarter of A squared C squared, that's the area of triangle AOC square, right? Area square. And a quarter of A squared B squared, that's a square of the area of triangle AOB. A quarter of B squared C squared, that's a square of area of triangle BOC, right? Then we just proved this. Okay, that's our first video for the geometry treasure. I will do more and hope you like this. See you in next one. Thank you.